Welcome to the Chapter 4, Section 4 podcast on acceleration. And the main idea with this section is about how to calculate acceleration. And you can calculate the acceleration of an object by dividing the change in its velocity by the time. So, you can change state of motion of something by changing its speed, slowing up, or speeding up, or by changing its direction of its motion, or, for that matter, both. In both cases, your velocity is changing. So we say that the acceleration is the rate at which velocity is changing. And here's the mathematical formula for it. It's the change in velocity over the time interval. So, and when we talk about acceleration, we're also talking about decreases as well as increases in speed. This is important because whenever we think of acceleration, we almost always think of increase, but it also can be a decrease in acceleration. And a fancy word for decrease in acceleration is, a decrease in acceleration is deceleration. Here I showed you a picture of brakes of a car to help you remember that. So once again, acceleration is a change in its state of motion. So we have a car here going towards a cliff. It was speeding up here, it's slowing down here, and now as it's going over a hill, it's changing its direction in that it's going upwards, then it's leveling out, and then it's going downwards. So the mouse down here is reminding us that there are actually 3 instruments you can use to change the motion of a car. The gas pedal, which helps you accelerate, your brakes, which helps you decelerate, and your steering wheel, which changes your direction. So once again, reiterating that, it's also going to be a change in direction of a car. Now, here's speed and velocity. Acceleration is not the change in speed, it's the change in velocity, not speed. The reason why it's not a change in speed is speed could be a speeding up or slowing down, but it doesn't take into account direction. Acceleration is a vector quantity because it talks about the change in velocity, which is also a vector quantity. Acceleration can be directional. So here we go. Let's look at this again. Let's look at these little arrows up here. Here's a car that is speeding up. Here's its velocity. It's going in that direction at that velocity, and it's accelerating. So we show the acceleration also as a vector arrow. Now, the velocity is slowing down. You can see the blue arrow is now shorter as it's slowing down as it gets close to the cliff. Our acceleration is actually towards the back of the car. It's actually in the opposite direction of velocity because we're trying to slow down. Now, the car goes over the cliff, and you can see now our velocity has changed direction. It might actually be still the same magnitude, but it's changing direction. And our acceleration now is it's going downwards because gravity is pulling it downwards. So it's picking up, it's changing its velocity in the downward direction. So we're often going to use speed and velocity interchangeably if we're talking about something that's going in a straight line. But so we'll often talk about acceleration as a change in speed over time. So excuse me, don't let that throw you off if I start talking about speed when we're talking about acceleration, because often we're talking about something moving along a straight line. So what's the units? The units of speed and acceleration. Well, the units of speed and velocity are units of distance per units of time. So if acceleration is a change in velocity or speed per time, then the units are going to be speed per time. So let's look at this example. We have something changing its speed, once again straight line, and it's going from 0 kilometers an hour to 1 kilometer an hour in 1 second. So we put our change in speed up here, which is 0 to 10 kilometers per hour. So it's going to be a change of 10 kilometers per hour, and that's going to occur over 1 second, which is our time interval. So we end up with this very strange looking unit, kilometers per hour per second. That's a unit of speed, kilometers per hour, over or times a unit of time. seconds. This seconds is in the denominator here. If you look at it, so it's often a unit of distance divided by a unit of time divided by another unit of time. We're going to say this as kilometers per hour second. Here we go. The unit of time appears twice, once for the unit of speed and once again for the interval of time in which the speed is changing. This is very important that you remember how these units work. It's a unit of speed over a unit of time, or a unit of distance divided by a unit of time divided by another unit of time. Let's do an example here. We have a car that's going from 35 to 40 kilometers per hour in 1 second, then 40 to 45 in 1 second, and then 40 to 45 to 50 in a second. So what's its acceleration? Well, each second it increased by 5 kilometers per hour each second. So therefore, its acceleration is going to be 5 kilometer per hour seconds. Here's another one. In 5 seconds, a car moving in a straight line increases its speed from 50 to 65. So it's a change of 15 kilometers per hour faster. And a truck in the same time goes from rest to 15 kilometers per hour in a straight line. Which undergoes the greater acceleration? Well, from 0 to 15 kilometers per hour is also 15 kilometers per hour. So they both have the same acceleration, 15 kilometers per hour per the time interval. So their acceleration is going to be the same. So how do you calculate acceleration? You calculate acceleration by dividing the change in its velocity by the time interval it takes to change that velocity.